This is a quick lesson just on acid-base reactions and neutralization reactions. We're going to look at acids and bases and salts and how we describe their reactions in water. So we'll get started. Let's just start with hydrochloric acid, HCl. And we're going to show this reacting with water. So plus H2O. Okay, now we recognize this as an acid because there's a hydrogen out in front. Okay, that hydrogen will get donated over to water. I guess I'll just draw an arrow over like that. Okay, and the reaction for this is going to make H3O positive plus what's left over, just a chloride ion, so Cl minus. So all we do is show the hydrogen, giving it over to the water, making H3O positive and Cl minus. So that's what acids do. Let's practice another one. And let's take nitrous acid, HNO2. This, of course, has a polyatomic ion. Now, again, we recognize that this is an acid because there's a hydrogen out in front. And we can react that with water, H2O. And again, products for that, the hydrogen is given over to water to make H3O positive. And then whatever's left over, we just rewrite, plus the nitrite ion, NO2, minus 1. Okay, so that's what the acids are. Again, we recognize them because there's a hydrogen out in front in each case here. So now those are simple definitions for acids, and that's all we're going to do. Okay, now what about bases? Okay, bases in water. We can recognize a base because there's a OH or hydroxide ion behind. Okay, and then we keep this as a simple reaction. We just show that the sodium and hydroxide are going to split apart in water to make aqueous ions of sodium, positive 1, and then write an AQ next to that, meaning it's mixed with water. That's what the AQ stands for, aqueous. And then plus an OH ion, like that, and then write that as aqueous as well. So we just show the OH and the Na just splitting apart in water, and that's a very simple look at what bases do in water. Now let's try another one. Let's try lithium hydroxide. So again, we're going to recognize this as being a base because there's a hydroxide in its formula. So we go over here, and then we'll just split those apart. Lithium positive 1, aqueous, plus the hydroxide, OH minus aqueous. And if you remember from our compounds, the first ion is always positive, the second one will always be negative. So that's how we show how bases react with water. So very, very simple definitions here. There are, again, more complicated definitions of bases as well, but we're not going to worry about that. Now, what about salts? Well, salt will not have an H or an OH in its formula, and those are just all the compounds that we've done previous in the year. So like NaCl would be a good example. Okay, and we're going to show no reaction in water. So I'll just put N period R. And again, some salts do react with water, and we're not going to get any details with that. But for right now, we're just going to assume that our salts are neutral, meaning they're not acids, they're not bases. And we'll show no reaction in water. But like I said, there are more complicated ways of doing acids and bases and salts that we're not going to do. Okay, what about let's say we have potassium nitrite. So again, there's not an H out in front, there's not an OH, so we're going to say no reaction. So the word salt really is a very general definition. You're used to just saying table salt, NaCl, but any of the compounds that can be made from acids and bases, they do produce salts, and we'll be looking at the neutralization reaction soon. Okay, what about, let's say we have something a little bit more complicated like aluminum sulfate. So I've got Al2 parenthesis SO4 parenthesis 3. Well, again, there's not a hydrogen out in front. There's not a hydroxide in the formula, so we'll assume this is a salt with no reaction. Okay, so for us, we're going to call salts neutral. And again, in more advanced situations, the salt may be a little acidic or basic, but we're going to ignore that. So we're going to just call salts neutral. Bases, we're looking for an OH in its formula. And for acids, we're looking for an H positive in its formula. Okay, now what about neutralization reactions? Well, the general equation for this is we're going to take an acid, okay, and we'll react it with a base. And we're going to produce some kind of a salt plus water. So they're called neutralization reaction because the products are neutral. Okay, so a salt is neutral and water is neutral. Now again, some salts are basic, some salts are acidic, but for our purpose, we're going to assume that they're all neutral. So we start with acids and bases and with neutral products. That's why it's called neutralization. Let's just do a couple of examples there. So we'll have sodium hydroxide, NaOH. Okay, we recognize that as a base because it has the OH in it. And then plus HCl. Of course, that's an acid because it's got the H in it. Now, do you see OH and H can come together and just make water? And then we just write whatever's left over together. So this would be NaCl plus H2O. As simple as that. Let's take KOH and react that with, let's do nitric acid, HNO3. So again, we see the H and the OH are going to get together to form water, and whatever's left over will form the salt. So that would be KNO3 plus H2O. Okay, it doesn't get any more challenging than that. So that's our acid, base, and salts in aqueous solutions.